Railway electrical engineering. How to work in electrical installation. First, electric traction distribution or railway overhead system with power supply. Work in a section for maintenance or to chase breakdown or any other shutdown program. First, you need to switch off the power of that particular section. Within 2 meters of overhead equipment, if you want to work, then you need permission of an authorized agency like traction per control or in station the station master in the unimportant lines. So first you have to take a permit to work. Then before giving this permission, they will switch off that section. Switch off the section maybe with load switch which is remotely controlled, but sometimes we need isolation with single pole isolator or an substitution double pole isolator, triple pole isolator. So isolation after this isolation you have to provide earthing at least distinct to earth rod with distinct to earth rod, because the live which we are having up and down lines, so many multiple lines. One line may be switched off, but other line will be energized. So the induction effect on the dead OHE, if you don't touch, is appreciable to electrocute. So be cautious. Though your section is dead, and if it is without earth, till it is almost live, around 2 kV from the live overhead conductors of the other track line. So be cautious, provide earthing. Then railway traction rail is a very good conductor because it is connected on the common earthing system of the substation and also the substation everywhere. So it is a good earth. And all non-current carrying metallic parts beside the railway track must be connected with this traction rail, so that it will attain zero potential. And if it is zero and you have some body resistance, so the rule of the electricity is to pass through low resistive path. It will not affect you, it will pass through that way, it will not come to you if you are in parallel with this path. But if you are in series with this path, then the current will flow through your body to the railway track. So there is the question: parallel of the earthing system and don't come in series. What is the series connection? Suppose the railway track is 13 meters long each piece. So after each 13 meter, some arrangement is done to join it. It may be welded joint or it may be by fish plate. But during track replacement, suppose it is a single line and you have opened one railway track. Now this quantity is the railway track is running far from this place and there may be an electric loco. So this electric loco's current will flow to the substation through this traction rail. And if you come when the rail is opening. If you breathe, your body is breathed by two legs or two hands in series with this track. That means the disconnected track and the track not disconnected. If you are touched, breathe these two rail, the current will flow, the return current will flow through your body. The question is series and parallel. Don't come in series with the return path of the electric current if it is mainly single line. But double line, multiple line, we are providing cross bond, so the current will flow that way because its resistance is too low, very low. Now, before opening an offload switch means single pole isolator. Our single pole isolator is provided on the top of the mast with insulators. The isolator is on the insulator so that the mast and the isolator blade cannot be breached. There must be an insulation. Now, sometimes some birds are falling some foreign body on on the blade of the isolators. So what happened? One of the staff went to open the isolators and he did not notice the connection from mast to the traction rail, that is bond. It is a low resistive path. If any mistake is there, then it will flow through the traction rail through this bond. It will not touch. But the bond is opened, maybe during engineering or some other means the bond was open, and when he has opened the isolators, the foreign body has touched the blade to the mast and immediately he got electrocuted. He was electrocuted. So be serious. Before opening an isolator, first you see the bonding connection with the traction rail, or in substation, it has two duplicate connection with the earth, with the common earthing system. It should not be cut, it should not be disconnected. Very cautious for this thing. Okay. And when you operate this thing, the fellow has used slipper, that means chappal. So it is also a bad thing when you are working, you are using chappals. Though in so many times in safety awareness, it has been told, but most of the staff not following it, casual about their safety. So use hand gloves when you operate the isolators, electric shock proof shoes, helmet, anti-falling device, etc. Okay. Now figure will show how the fellow has electrocuted. Figure shows an electric mast, traction mast just beside the railway track. As per the safety, it is non-current carrying because all the OHV materials above 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 the mast, not above the mast. We are fixing cantilever everything, but the insulation is the insulators, and for isolator it is also post insulators. So the mast is dead, but above the insulators, these are all live. Above, or which is connected with the insulator, that is all live with 25 kV or some higher voltages in the substation. So it is our safety that the insulator is protecting us, but it is not enough. So what we are doing, we are connecting a connection which is shown in red color from the mast to the railway track. It is called bond, structure bond. It plays a very important role for our safety. Suppose any insulator has broken, immediately it will touch the mast and 25 kV will energize the mast, but it will not affect you because If you touch the mast, it will not pass through your body because the low resistive path with this bond, it will return to the substation and the circuit breaker will trip immediately through the relay. It is an earth fault. It is an earth fault. So our safety mainly depends on this bond, structure bond. Even we are providing to discharge, or sometimes engineering departments or other departments work on the track and bond remains disconnected, but some possibility is very rare because the systems after work they will provide the connection, but some human mistake is occurring. So this is the protection. But what happened in the Bokaro? The isolators, the fellow has gone to open the isolators. He has not checked the bond, this structure bond, and open it. A foreign body was present on the movable blade, and when he opened it, the live end to dead end. Dead end means the earth end. This Oichi mast, a foreign body, a string, steel string touched it, and when he opened it, he was electrocuted because the bond is disconnected from the traction rail. From the traction rail. So be careful. This is the system of working in the traction distribution system. Another thing is contractors not informing any authority erecting mast beside the railway track without any permit to work. Though it is not acceptable, they must be punished if any mishap will occur. They are full, but in that case, simply in the bottom portion to the mast, if they will connect with the traction rail, our CV will trip, which may be snapped, but they will be safe. But it is a mistake. I can't say it is a crime. Take permit to work from the proper authority. Then you do all these things. Otherwise, in Dhanbad division, our portal connection was there. That means when our numerous truck is running in the station, was providing a portal of diverse usage. That means it is covering all the tracks, and then two end is connected with the earth, not earth, it in the platform. But this portal must, both ends, must be connected to the traction rail. But it was missing, and some people sat on the sat on the portal base. One cross short circuited, one insulator of the cantilever, and immediately few person electrocuted, and the end of their lives. So this has tremendous importance. This bond, structure bond, you must follow it. Don't do any mistake. Don't direct anything close to the electrified section which may entangle with the OHE or overhead equipment without any particular protection, mainly permit to work, making the section dead, provide only then. Otherwise, don't do it. To work in electric locomotives, sometimes we have to work in the mid section due to its failure or other things. So to work in the locomotives, mainly in the HT component and everything, you need first to switch off power in the locomotive by opening its circuit breaker, then lower the pantograph to disconnect from OHE. Then in HT compartment, you add the locomotives with HOM handle. So this is the system, and in said it is fully safe because the section is isolated by two neutral section in both ends. When the work will continue, the section will be earth, and when you charge it, the earth will be removed. This is mechanical arrangement and somewhat reliable. So this is the system in the locomotive. See how it's working. The locomotive is shown here and it is in dead condition. Earth has been provided after the neutral section, so staff are fully safe. Now to charge the section, you first close the single pole isolator. Though the section at that time it will not charge because the power supply is coming from the other end, double pole isolator end. But it will remove the, if you close it, it will remove the earth of its own. Which earthing is connected with this isolator, it will be removed, because if you close the double pole isolator first, the earthing will be present in the single pole isolator and circuit breaker will trip. So first you close the single pole isolator and remove the earth. Next you close the double pole isolator and power supply will go up to the SPI neutral section and its earth will be removed automatically when it will close it. To switch off power, you have to follow the reverse sequence. First you open the double pole isolator, then the single pole isolator. First, when you will open the double pole isolator, the power supply will be cut from that section. Then you open the single pole, because if you don't open the double pole isolator first, you first open the single pole isolator, it will be earth and supply is made through to the double pole isolator, the circuit breaker will trip. So the sequence is first you open the double pole isolator, then power supply will be cut, its earthing system will be removed. Then you open the single pole isolator, its earth will be provided, and the section is safe. Both double pole isolator and single pole isolator earth is provided, and you can work now.